We are still on Match 103 Subsidiary Mathematics. This is elementary calculus. We'll be treating evaluating implicit functions at a point. We want to evaluate implicit functions at a point. Now, let's see the steps which we can use towards evaluating implicit functions at a point. Step 1, find dy dx by implicit differentiation. Then step 2, evaluate dy dx at a given point xy by substituting the values of xy in dy dx. So first you have to find what dy dx by implicit differentiation. Don't forget, I said with implicit functions we have x and what y, but make sure that you have to treat what y in terms of the area x. You have to treat y in terms of x. Alright, so it means that when you get any y term, you have to differentiate that. You won't treat it as a what? As a constant. But you have to differentiate that with respect to what? X. So if I have y squared, if I differentiate y squared with respect to x, I get 2y, but then don't forget your dy dx. So 2y times my dy dx. So we evaluate dy dx at what? A given point xy by substituting the values of xy in what? Dy dx. So now let's start with examples. Given that 2x cubed plus 3xy squared minus y cubed plus 6 equals 0, find dy dx given negative 1, 1. So this is your x value and this is your y value. So you have to find, or we have to find for dy dx. You have to find dy dx. So let's see, by implicit differentiation. So 1, I have 2x cubed plus 3xy squared minus y cubed plus 6 equals 0. So how best can we find for what? Dy dx. So we have to what? Take the derivative of this function with respect to what? X. So I have d dx of 2x cubed plus d dx of 3xy squared minus d dx of y cubed plus d dx of 6 equals d dx of 0. So this is how we are moving. So you take d dx of 2x cubed, then d dx of 3xy squared minus d dx of y cubed plus d dx of 6 equals d dx of 0. So now let's see. If we are differentiating 2x cubed with respect to x, always don't forget to drop the exponent, so the 3 will drop, then it multiplies what? The coefficient of x cubed, which is what? 2. So I get 3 times 2, we obtain what? 6. Then now we subtract 1 from the exponent. The total exponent is what? 3. So we subtract 1, which will obtain what? 2. Right. Then now let's move on to the next thing. Now the next thing we have 3xy squared. 3xy squared. They are multiplying. And this time around, they said we should treat y as a function of x by implicit differentiation. You have to treat y as a function of x. So I have my 3xy squared, which means that if I'm treating y as a function of x, then what should I do? Then I have to apply my product rule. I have to apply my product rule, which means that if I'm treating y as a function of x, then it means that my 3x is multiplying y squared. So I have to treat what? Y as a function of x. So we apply the product. Good. So now let's see. The whole of this is what? U. And the whole of this is what? V. The whole of this is what? U. And the whole of this is what? V. And with our product, we said that what? U dv over dx plus v du over dx. Which means that we hold what? U constant, then we differentiate v with respect to what? X. Then we hold v constant, then we differentiate what? U with respect to what? X. So now let's see. So my U is 3x. Then I differentiate v with respect to x. We get 2y. We subtract 1 from the exponent, so we get 1. Then don't forget your dy dx. Dy dx plus v. What is v? Y squared times. We differentiate u with respect to x. So if you differentiate u, which is 3x, our exponent here, the total exponent is 1. So when it drops, it multiplies with the coefficient of x, which is 3. So 1 times 3, you obtain it. 3. Then you subtract 1 from the total power, which is 0. So x to the power 0 is what? 1. So we have this. So now 3x times 2y, you get 6xy. Then my dy over dx, then plus 3y squared. So we have this as our answer here. So now let's proceed. So I can write the whole of this there. So I have my plus 6xy dy dx, then plus 3y squared. Then now we have d dx of y cubed. So we get what? Plus 3y squared dy dx. Then when you differentiate x with respect to, when you differentiate 6 with respect to x, we are differentiating a constant. There is no x term here. So we are differentiating a constant with respect to x, we get 0. 0. Then, which must be equal to the same constant, 0. So we equate it to it. 0. It's still 0. So we have this. So now let's see. So what do? We have to group our dy dx. Don't forget. Our last tutorial, what we were doing, the same thing, how to differentiate implicit functions. So we have divide x here, divide x here. So we group them. So I have my 6xy dy dx, then plus my 3y squared dy dx, then equals, we have no divide x here, so we set it. So I have minus 6x squared, then here minus 3y squared. So this is what we have. Then what do? We have to factorize dy dx. So we divide the x out. So we get 6xy plus 3y squared. So we have this equals minus 6x squared minus 3y squared. Then what do? We have to divide both sides by 6xy plus 3y squared. So 6xy plus 3y squared equals minus 6x squared minus 3y squared. And here to the same thing. So this guy cancels. So we have y dx, which is equal to negative 6x squared minus 3y squared, all divided by 6xy plus 3y squared. So we have this. We have this. Which is very, very simple. Very, very simple. Although you can still factorize. You can still factorize. If you don't want to factorize, don't worry yourself. Let's proceed. So now they say dy dx, given that negative 1 what? 1. So Wherever I see x, I substitute -1. And wherever I see y, I substitute 1. So I have -6. Then x is what? -1. All squared minus 3y is what? 1. All what? Squared. Divided by 6 times my -1 times my 1 plus 3 times what is y? Y is 1. All what? Squared. So this one we have, here I get 1. Then here you get -3, all divided by 6 times -1 times 1 is -6. Then here you get plus 3. So which is very, very simple. -6 plus -3 will obtain -9 divided by -6 plus 3 will obtain -3. So this guy they go away, then we obtain what? 3. So my dy over dx giving -1, 1, the answer is positive what? 3. Positive 3. Positive 3, which is very, very simple and very, very trivial as well. So kindly look at it very, very well and go through. So I'll do my question 2a. So let's proceed. Alright, so let's see. 2y cubed plus y squared minus x equals 0. So we differentiate with respect to what? X. So I have 2y cubed then plus dx of y squared minus dx of x equals the same thing, dx of 0. So now, let's see. We differentiate 2y cubed with respect to x. Don't forget, we are treating y as a function of what? X. So 3 multiply the coefficient of y cubed, then we obtain what? 6. Right. So I'll get my 6y, then subtract 1 from the total power. Then plus, don't forget dy dx, then plus dx of y squared. So we get 2y dy dx, then minus dx of x. We differentiate x, we get 1 equals dx of 0 is 0, which is a constant. So let's factorize. Dy dx out, we get 6y squared plus 2y equals, okay, so we get 1. So -1 crosses the equal sign, or we transpose -1, we get positive 1. Right. Then we divide both sides by what? 6y squared plus 2y. 6y squared plus 2y equals 1 over 6y squared plus 2y. Away, right? So I get my dy dx equals 1 all over 6y squared plus 2y. Now, you see that where x is 3, y is 1. So I have my dy dx giving 3, 1, which means that this is my x, this is my y. So I get 1 over my 6 times 1 squared plus 2 times x is what? 3. So I get 1 over 6 times 1 all squared. It's the same thing as 6. 1 squared, 1 times 1, and it multiplies 6, you get 6. Plus 2 times 3, we obtain 6. So we get 1 out of 6 plus 6, we obtain 12. So that's my dy dx given 1. So that's the point. Giving the point what? 3, 1. So we get 1 out of 3. So that's the slope. That's the slope. Using implicit differentiation. Using implicit differentiation. Alright. So we end here. Since I have my examples are not main, right? So I've solved question 1 and question 2. So try as much as possible to solve question 2b and question 2c. Then You can WhatsApp me or you can drop it at the comment section. I'll get time and read it. Alright, so we end our tutorials on evaluating implicit functions at a point. Then we move on to how to differentiate trigonometric functions. Thank you for subscribing. Have a nice day. Bye-bye.